Hello, grade 7, and welcome to the 8th math session in our lesson, which is triangles. In this session, we are going to start talking about lines in triangles. What are the remarkable lines in a triangle? We are going to talk about medians, bisectors, heights, and perpendicular bisectors. First of all, we are going to start with the medians in a triangle. Let us just back up what is meant by the midpoint. The midpoint of this segment is the point that is located in the middle. Midpoint in the middle of this segment. Example, we have AB. Its measure is 10 centimeter. Its midpoint is located at 5 centimeter, which cuts the segment into two equal parts, such that AM is 5 centimeter and MB is 5 centimeter. So in this case, we say that M is the midpoint of segment AB. We can only draw midpoint for a segment. Now, what is a median? A median in a triangle is a segment that joins a vertex of the triangle with the midpoint of the opposite side. To draw a median, we just need a ruler to find the midpoint. How to draw it? First of all, we mark the point D, since we are going to draw, in this case, the median AD relative to the side BC. We measure the length of BC and we mark point D, the midpoint. Then we join A and D to get the median AD relative to the side BC. Now let's start drawing the medians in the triangle. So we will repeat. What is a median? A median, as we said, is a segment that joins the vertex with the midpoint of the opposite side. Let's take this triangle ABC. Now we want to start drawing the median AM relative to side BC. So it should be issued from A to the opposite side, which is BC. It will be from A to the midpoint of BC. So M will be the midpoint of BC. To draw the median, I'm going to use the ruler. Measure BC, it's 8 centimeter. Its midpoint is at 4, which I will call it M. Okay, I'm going to put quotes such that BM is equal to MC. Next, I'm going to join the segment AM. This is the first median, AM. Second, CN is the median relative to AB. CN, it's issued from C to the opposite side, which is AB. AB is the opposite side of C. So N will be the midpoint of AB. Let's measure the length of AB. It's 5 centimeter. Its midpoint at 2.5 centimeter. Its midpoint is N. And let's put the quotes. AN is equal to NB. Now we have to join CN to get the second median. Now draw BK, the median that is relative to AC. BK from B to the opposite side, which is AC. From B to the opposite side, which is AC. So K is the midpoint of AC. So we have to measure AC and find its midpoint, which cuts the segment AC into two equal parts. Then we join B with K to get the third median. Now look, what do we notice? We notice that the three medians are concurrent. It means they intersect at the same point. In this case, I'm going to name the point G. But the point G has a name. In all cases and in all triangles, the three medians intersect in one point, which is called centroid, or the center of gravity. Pay attention. You don't have to draw the three medians to draw the centroid. It's enough to find this point of intersection to just draw two correct medians. Okay? Now let's talk about heights in a triangle. Okay, before talking about the heights, we are going to review what is meant by perpendicular lines. Perpendicular lines are lines that make a right angle, 90 degree. We draw perpendicular lines using a set square. Let's make an application. Draw line D, which is perpendicular to AB and passing through C. When I say passing through C, it means perpendicular to AB and the right angle must be on AB. So we put the set square in this form where the right angle is on AB. One side of the set square is on AB and the second side is passing through C. Now we are ready to draw the perpendicular line. This is the perpendicular line of AB which passes through C and make a right angle. Now take a note. From a given point you can draw only one perpendicular straight line. Okay? You can draw one perpendicular straight line to a given another straight line. Examples, if I want to draw a perpendicular line to AB and passing through C, in these three cases, we have to line up the set square correctly. One side should be on the line AB and the second side must pass through C. In each of the following cases, as you can notice, the set square will make a right angle. This is a perpendicular line. Now let's talk about the height in a triangle. What is a height? A height is a segment issued from the vertex perpendicular to the opposite side of the triangle. This is triangle ABC. Okay, in first case, AM is a height relative to BC. So from A, I want to draw a perpendicular line to BC. So it's passing through A and perpendicular, making a right angle on BC. So using the set square, line it up correctly. One side on BC making a right angle and the second side passing through A. Now we are ready. Let's draw the first height. It's a segment. Okay, the first height is AM, making a right angle with BC. Now, this is AM, the first height issued from A relative to BC. Now, let's draw CN, height relative to AB. So, it's issued from C to the opposite side, which is AB. Putting the set square, one side on AB, making a right angle on AB, and the second side must pass through C, okay, making a right angle. So this height is CN, which is passing through C and perpendicular to AB. The last one, which is BK, the height relative to AC. So it's passing through B and perpendicular to AC. Putting the set square correctly, one side on AC, the second side passing through B and making a right angle with AC. This is the third height, which is BK. Look, the three heights intersect in one point, so the three heights are concurrent. This point, we name it O, it's the orthocenter. It's the point of intersection of heights. Okay, take An important note, as we said in the medians, it's not necessary to draw the three heights to get the orthocenter. It's enough to draw two correct heights. They will intersect in the same point, which is called the orthocenter. We have other cases of the orthocenter. In the obtuse triangle, we have an obtuse angle. The three heights will intersect outside the triangle, so the orthocenter will be outside. In the case of the right triangle, the three heights will intersect at the vertex, which is the right angle. So this is the orthocenter at A, at the right angle of the right triangle. And by this, we finished our session. Thank you for watching. Goodbye.